Okay, so yesterday we solved some basic trig functions. Today we are going to solve more trig functions. Okay, and we are going to be using identities today to solve, which is why I had you write down that Pythagorean identity here. So when we are solving the equation, I've written down some steps to help you think about how you want to go about solving the cosecant squared equal to the cotangent of theta plus 3. Okay, so many times the first thing that you're going to want to try to do is to rewrite with one trig function if you can. So in order to help us rewrite with one trig function, we want to use those Pythagorean identities. So the one that we know and love by heart, that sine squared plus cosine squared equals 1, we can create the other ones from that. Do you guys remember how to create the next one? Oh, that would be, so this would have the 1 minus sine squared equals the cosine squared. What about the ones with the other functions in them? Yep, divide everything by. Okay, so if you divide everything by sine squared divided by itself is 1. What's cosine squared divided by sine squared? Cotangent, yeah. So we have the cotangent squared. And then 1 over the sine is going to be the cosecant squared. Okay, and then see if you can write down the last one. Because you have to divide everything by what for the last one? So we divided everything by sine. Now sine squared, then we're going to divide everything by cosine squared. Okay, so sine squared divided by cosine squared. Jaden G, what's that going to be? That's right. So we got the tangent squared plus, and then we know the cosine divided by itself is going to be 1. All right, and then you know what is 1 over the cosine going to be equal to? 1 over the cosine squared. The reciprocal. What's the reciprocal of the cosine? Yeah, the secant. I was going to say, it's our main today, right? Yeah, good. Okay, so now looking at these, we want to try to rewrite this with only one trig function. Okay, so what are our ideas? How can we do that? Yeah, first. You don't mean cosine, you mean the, yep. Good, so we're going to substitute. Okay, so we're going to substitute instead of the cosecant squared, okay, we can plug in 1 plus the cotangent squared of theta. So we're going to use theta here because that's what we have. Okay, so instead of the cosecant squared, I'm going to substitute 1 plus the cotangent squared of theta, and that's going to be equal to the cotangent plus 3. Okay, so we've done step 1 where we've rewritten with only one trig function. Now we're going to move all terms to one side to factor. Okay, and you have the choice of what side you want to move them to. I'm always going to try to move it to the side that's going to keep the cotangent squared positive. Okay, and then these are not like terms. You cannot combine them. Okay, so what we're going to have is the cotangent squared of theta minus the cotangent of theta. These are like terms, so it's minus 2 equals 0. Okay, if you find yourself having trouble processing how to do this with the cotangent, then you can always think of it like this. Instead of the cotangent squared, just think x squared minus x minus 2 equals 0. Okay, because we can factor that with ease. And then once you factor that, you can apply it here. Okay, so I do want you to go ahead and factor that right now. So once you factor, I want you to keep going. I want you to set each one equal. Then we're going to use some of our strategies from yesterday. Okay, what's nice about factoring this is you have a prime value. So you have the cotangent and the cotangent that multiplies to negative 2. It's just 1 and 2. Okay, the 2 does have to be negative, but it doesn't matter if you have the minus 2 first or the plus 1 first. And then we're going to set each one equal to 0 to solve. Okay, so we have the cotangent of theta minus 2 equals 0, or we know that the cotangent of theta plus 1 equals 0. Okay, so if we solve, we have the cotangent of theta equals 2, the cotangent of theta equals negative 1, and we can use our unit circle to see where the cotangent is 2 and where the cotangent is negative 1, but we're much more familiar with tangent than cotangent, right? So do you guys remember what we did yesterday? Yeah, we used the reciprocal, right? So you can use the reciprocal. You can rewrite as the reciprocal. So if it's cotangent, the reciprocal is our tangent. The reciprocal of 2 is 1 over 2. And we can do the same thing over here. So this would be the tangent of theta. And what's the reciprocal of negative 1? Negative 1. Okay, so one thing that you might want to have out today is your 7-4 note sheet from yesterday, because we have this handy dandy unit circle on here. We might want to reference that. Okay, so we have like root 3 over 3. We have 1, root 3. Okay, and then we can see negative 1. And negative 1 is 3 pi over 4 and 7 pi over 4. Okay, you can also do that without looking at the unit circle, because we know that pi over 4 is 1. Okay, so we know that 3 pi over 4 would be negative 1, because all students take classes, right? Okay, so 3 pi over 4 and 7 pi over 4, okay, are the values where the tangent is negative 1. But remember, for tangent, because they're across the circle from each other, they have that pi relationship. They're pi radians away from each other, that your theta is only going to include one equation. So it's 3 pi over 4 plus pi k. Remember, that's not the only way that you can write that. So you have several ways that you can write these. So another acceptable answer would be 7 pi over 4 plus pi k. What's one more common answer that you could write that as? Yeah, thank you. Negative pi over 4 plus pi k. Okay, so you can say 7 pi over 4 and negative pi over 4. Okay, whichever one you want. Okay, so you're only going to write one of those. Okay, and then for 1/2, well, that wasn't in these values that we wrote down. So if it's not a special place on the unit circle, what do we have to do? What do we have to do if it's not on the unit circle? Tanya, what do you think? That is correct. Okay, so if it's not an exact value, would have been fun if I gave you a challenge card today and it was you had to sing or anything, then you could respond to me. You gotta get your calculator. That's it. That's gonna be it. That's gonna be one of the random challenges. If it's not an exact value on the UC. Yes. Use on the undercover. Use the inverse on your okay, and remember when you use that inverse function, you have to make sure you're in radian mode. So we're doing everything in radian mode here. Okay, and the beautiful thing about the tangent value is you only need one equation. Okay, so go ahead and do the inverse, and then I want you to write out that equation. And then let me know if you need a calculator. All you need is a scientific one today, so. All right, so you should have 0.46 plus pi k. Okay, and again, that's the only one that you have to do for your tangent. All right, and then for part B, you have 3 sine of 2 theta minus 2 sine of theta equals 0. Okay, so when you have something like this is your double angle identity. Okay, so the sine of 2 theta, okay, that's going to be something that you can use your formula sheet for. So we know that the sine of 2 theta is 2 sine of theta cosine of theta. So when you see the 2 in front like that, it's not squared. It's going to be your double angle. So that's what we're going to substitute into our equation. Okay, so it's going to be 3. We're going to substitute that in minus 2 sine of theta. now here, you do have to multiply the 3 times the 2. So it's 6 sine of theta cosine of theta minus 2 sine of theta. And before, we wanted to rewrite everything with sine and, we wanted to rewrite everything with one trig function. And this one you have 2 trig functions, the sine and the cosine, but neither of them are squared. Okay, so if these are not squared, you cannot use that Pythagorean ID. You can't use anything from sine squared plus cosine squared equals 1. So another strategy is if you can't rewrite with only one trig function, you might be able to do something else. Can you guys see what we can do to this? Yeah, you can factor. Okay, so if you can't rewrite, another strategy is going to be to factor. Okay, so we're going to factor the GCF. Okay, so in addition to rewriting with only one trig function, you can also use your identities, you can factor. So for this, not only do you have the sine function in common, with 6 and 2 you can take out a number as well. Sometimes you won't be able to take out the number, and that's okay. Okay, but here, 6 and 2, you can take out a 2. You can also take out a sine. I want you guys to write what is left over and then set up your 2 equations. Okay, and go ahead and solve that. All right, Sue, when you factor this out, what did you get inside? And then, yep, that's okay. You just subtracted. Okay, yep, 3 cosine of theta minus 1. Great. Okay, so 6 divided by 2, and then negative 2 divided by 2. Okay, so we have 2 sine of theta equals 0, or 3 cosine of theta minus 1 equals 0. Okay, so we're just going to solve. So we divide by 2. So we have the sine of theta equals 0. So when you were trying to solve this, you were trying to find where on the unit circle is the y-coordinate 0. Okay, so for theta, actually, will you guys write down the place or places where the sign value is 0? You can look at your unit circle. Yep, and then find your theta. Okay, and then Jaden, see where is one place that the sign is 0? Yep, so at 0 it is 1, 0. Okay, and then the radians are 0. Okay, and then Gabe, where's the other place? Yeah, pi. Yep. So negative 1, 0. So 0 and pi. Did some of you say 2 pi? Okay. So 0 and 2 pi are the same. Okay. So it doesn't matter to me which one of those you put. And this is special special for sine. Do you guys see how they have that relationship that's across the circle from each other? Okay, so you are going to pick one of these and you are going to write your equation. If you pick 0 plus pi k, just know you can simplify that to pi k. Okay, we'll write out all of our solutions over here because there's going to be more. Okay, but for the first one, you can just write pi k. Make a larger box because we're going to have more. But for this one, or you could have pi plus pi k, that would be fine. Or even if you had 2 pi plus pi k, that would be fine. Okay, so whichever one you have for that of these three is good. All right, now let's return and solve this one. So you would add 1, then you would divide by 3. I am fine if you just jump to this. The cosine of theta is 1/3. Okay, now that is not on the unit circle. So when that happens, you have to do the cosine inverse of 1/3. So we're going to calculate that. So we do the cosine inverse of 1/3. We get 1.23. Okay, that is going to give us another solution. So we can write 1.23 plus, and if it's one of these values, it's going to be 2 pi k. The only time it'll be like plus the pi k is if it has this relationship. Okay, and that only happens in certain places for sine and cosine. But remember, that is not all. Like we talked about yesterday, there's going to be 2 places where the cosine is positive. So this is the cosine of theta. This is the cosine of theta is 1/3. Okay? What that means is the cosine is positive in quadrant 1 and quadrant 4. You have the solution that's in quadrant 1, but you have to find the solution in quadrant 4. You guys remember that from yesterday? Okay, so there's a few different ways that you can do that. I like to draw a visual. When you are doing it on your homework on your own, you might not need a visual. That is fine. If you do, that is fine too. Okay, the easiest way to explain this is thinking of your unit circle. So we remember that this is 1.57, 3.14. Okay, so 1.23 is in quadrant 1. That measures this distance. Okay, we know the distance in radians is 1.23. To find the one in quadrant 4, we use the reflection, and then we have to find this angle. So we talked about a few ways that we could name this angle. Do you guys know how to calculate the angle? Yeah, how do we do it? Lucas, how do we do that? Yeah. Yeah, so 2 pi minus the 1.23. Because we know this here, this distance is 1.23. Okay, so we just have to subtract those. Okay, so in your calculator, we're going to do 2 pi. Use the pi symbol, please. Minus 1.23. Okay, so you could do that, and your other solution would be 5.05 plus 2 pi k. Okay, or if you wanted, what's another name for that angle? Negative 1.23. Yep. So, or you could do negative 1.23 plus 2 pi k. Okay, so that would be an option too. Okay, and for this one, I do think it's a very quick option, a valid option to use. All right, what questions do you have on page 1? about more trig functions. So, for example 2, it says an equation is given. You have to find all solutions and then find solutions in this interval, 0 to 2 pi. This must have been before I learned how to use math editor. Okay, so 0 to 2 pi. And this is the difference between them. When they are asking you to find all solutions, that means you're going to be writing an equation that represents an infinite amount of solutions. When you are finding solutions in this interval, you have to list the specific solutions that are between 0 and 2 pi. Okay? So we're going to list specific solutions that are between 0 and 2 pi. So your equation here is 2 sine of 3 theta plus 1 equals 0. Right? Now sometimes you might look at that and think, oh, is there an identity I don't know for the triple angle? No, you don't have to worry about that for this. Okay, so for this type of problem, we are not going to be substituting in using identities. What we're going to do is we are going to isolate the trig function. Okay, so we are going to isolate the trig function. So what we are trying to isolate is the sine of 3 theta. So I want you guys to write what the sine of 3 theta is equal to. So you're going to solve that for the sine of 3 theta. All right, Solomon, what'd you get for that? Yep. So you subtract the 1, divide by 2, negative 1 over 2. Great. Okay, now once you've isolated the trig function, you are going to take the inverse. So really what you're doing is you're doing the inverse of both sides. Okay, I'm not going to make you write it out on both sides every time. I just want you to see what is happening here. So when you do the sine inverse of the sine of 3 theta, those operations are going to undo one another. So you're left with 3 theta equals the sine inverse of negative 1/2. What that means is you have to find where the y-coordinate equals negative 1/2 on your unit circle. Okay, and there's going to be 2 places. Okay, so because there's 2 places, we're going to have 2 equations. Okay, if we were just doing this like we did before, we would just find that place and write out that equation. I want you to write out each equation for the sine inverse of negative 1/2. Okay, so you can use your unit circle here. Okay, so the sine is your y-coordinate. So it's negative 1/2 at 7 pi over 6. So we'd have 7 pi over 6 plus 2 pi k. We also have negative 1/2 here at 11 pi over 6, which you can call 11 pi over 6, or you can call it negative pi over 6. That part doesn't matter. And then from there, there's one more step. Do you guys know what it is? Yes. Now when you divide by 3, when you divide by 3, you also want to make sure that you divide both of these by 3. And yes, dividing by 3, when you have a fraction, it's a lot simpler to think of that as multiplying by the reciprocal. So 7 pi over 6 divided by 3 is what? 7 pi over what? Yeah, I'm looking at other people. I don't want to do one working here. Okay, so 7 pi over 6 times 1/3, right? It'll just be 7 pi over 18. And then you can keep this as 2 pi k divided by 3. Or if you want to write 2/3 pi k, that's fine too. And then we're going to do the same thing with this. Okay, so I want you to write out your theta. And that's going to be your answer to part 1. All solutions. Okay, so Zoe, once you've written down your solution, will you tell me what you got?
11 pi over 18 plus 2 pi k.
Good. Okay, so 11 pi over 18, 6 times 3 is 18. Multiply the 11 by the 1. Great, great, great. Okay, now we're going to go to step 2, which is to find the solutions in 0 to 2 pi. Okay, when you are finding the solutions in the interval, one strategy you can use is you can plug in non-negative integers for k. Okay, that is going to be equivalent to just adding these values, which is something that we did yesterday. Okay, and we're going to do this for each equation. Okay, so for the first equation, if you plug in k is 0, then you would just have 7 pi over 18. Okay, is that between 0 and 2 pi? Yes. And when your denominator is 18, it is helpful to think about it in terms of that denominator. Okay, so we are looking for solutions between 0 and what? 36 pi over 18, because 36 divided by 18 is 2. So yep, that's going to be in the interval. If you plug in k as 1, you would be adding the 2 pi over 3 to this value. That would be equivalent to plugging in k as 1. And then, of course, we want a common denominator. So we would multiply the top and the bottom by 6. So we'd be adding 12 pi over 18. So we're just adding the numerators. So we get 19 pi over 18. Okay, that's lower than 36. So yep, that's going to be one of the solutions as well. Okay, and now we're going to add it again. That's equivalent to plugging in k is 2. So I'm just going to write plus 12 pi over 18 now, because that's going to be easier to add. Okay, so if you add 10, you get 29. You add 2, you get 31. So you have 31 pi over 18. Okay, and then if you added 12 to that, it would be greater than 36, right? So we don't have to worry about adding it again. Okay, so those are part of our solutions. But now we also have to do that for this part for this equation. So if I plug in 0, I get 11 pi over 18. So that's one of our answers. And then we're going to add that 12 pi over 18. So I want you to keep doing that until you have found all of the solutions. And then we're going to organize those. All right, so Cedric, what'd you get when you added the 12 pi over 18 to the 11 pi? Great. So that is definitely going to be in there. And then could we add this one more time? Okay, and then what do we get for that? Yep, so then we can't add it anymore. Okay, so all of our solutions, for this one we have 6. That is honestly on the high end. I know yesterday you had to find 6 of the specific solutions for each. This just happens to be 6. Okay, but we're not going to have this many every time. Okay, this is on the higher end. Okay, so for 1, you have all solutions. Those are your equations. Remember to divide this part of the equation by the 3 as well. Okay, and then you find those specific solutions there. Okay, in part B, we have the tangent of theta over 4 plus root 3 equals 0. Okay, so your first step is always to isolate the trig function. Okay, so the theta over 4, that is your trig function. So we have to move over the root 3. Make sure that you do the opposite. Sometimes people just move it over and they forget it's subtraction. So we have the tangent of theta over 4 equals negative root 3. Okay, so then when you're doing the inverse, I'm fine if you just write this. It's the tangent inverse of negative root 3. Okay, so remember, the tangent functions are not written on your unit circle. So when you're trying to figure that out, I always think about how I know root 3 is here at pi over 3, and I can use the all students take classes to find where it's going to be negative. So it'll be negative root 3 here. It's going to be positive there. Okay, and then negative root 3 here. Okay, now with tangent, remember you only need how many equations? 1. So for the tangent, you only need 1 equation because the solutions are directly across from each other. That's why for this one, we're only going to have 1 equation, and for part A, we had to do 2. Okay, so you can pick. You can use the 2 pi over 3, or you can use the 5 pi over 3. I generally just use the one that comes first, but again, either one is correct. And then remember with tangent, it's pi k. You can remember because it is pi across the unit circle, but that's also the period for tangent functions. They repeat every pi. Okay, so I use 2 pi over 3. Okay, and if you want to use 5 pi over 3, you could. So now let's think about how we're going to solve this. So you have theta divided by 4. So if you just want theta, what would you do to both sides? Yep, you're just going to multiply by 4. So when you do that, it will cancel out here, but on this side, remember to distribute. Okay, so for step 1, for all the solutions, your theta is going to be 8 pi over 3. And if you need to, you can just put this over 1. 4 times 2, the 8 pi. 1 times 3 plus 4 times pi k is 4 pi k. So this represents all of your solutions. Okay, now in step 2, you can plug in k equals 0. If you plug in 0 for k here, okay, then you have 8 pi over 3. This is another reason why I use the smaller one on the unit circle, is because sometimes if you use the larger one, you might miss a solution when you get to this step because you have to plug in a negative number. Okay, so I do recommend using what comes first on the unit circle when you are doing step 1. Now, if we're looking for things in the interval 0 to 2 pi, remember that that is going to convert to what over 3? So what over 3 would be equivalent to 2 pi? 6 pi. Okay, so 8 pi over 3, that is greater than 2 pi. Okay, so guess how many solutions are in that interval? None. Because not even if you plug in 0 would you have that. Okay, and if you subtracted 4 pi, then you'd be in the negative values. Okay, so that wouldn't work either. Okay, so there's no solutions from 0 to 2 pi. Okay, so that does happen sometimes. All right, so this is another section where it's important that you get exposure to the different types of trig equations for you to be fully prepared for your next assessment. Okay, when you practice those different ones, that helps you identify different patterns, different strategies. Okay, so it's 3 through 9 odd, and then 17